very good morning. I bid to Dr. Ray and everyone. Today, my company is going to present about the optimal transformer sizing for our company called Tiger Biskuat Industry. The leader of this team is Tan Chong Chiat, me, myself, B. Yuni, Fatin Farha binti Nazaruddin, Ahmad Muslim bin Mak Rahim, Muhammad Badrul Munir bin Busu, and Nur Christina Iman binti Mahathir. Our company has developed a Microsoft Excel tool that helps to determine the proper industrial distribution transformer sizing. And this sizing has to fulfill three important criteria, which are: first, the total maximum demand of industrial loadings must be less than or equal to 65% of the transformer full load size. Secondly, the voltage drop due to largest motor starting at secondary must be less than 10%. And if the largest motor starts more than once per hour, the transformer size should be increased by 20%. So this tool developed will suggest 3 times to give more accurate output results.
Assalamualaikum. So today I would like to present the criteria 1 for this project. Criteria 1 is we need to make sure that the size of the transformer must be equal or more than 65% of the total maximum demand. Okay, so this Excel tool requires the user to insert all the details about their load. And then the utilization and diversity factor is not constant, but it depending on how frequent the load being used in one day. Okay, then after insert all the details, this tool will automatically calculate for them their total maximum demand.
My name is Nur Christina Iman binti Mahathir, 88170081. So after user has inserted all the information and data in the green column on the table above, the second table will calculate the total maximum demand, and according to the first criteria, which is 65% more or equal than the total maximum demand. The transformer full load size must be 65% more or equal. So the total maximum demand will be divided by 0.65 and the value will be 1316.92. So this value will be satisfy the first criteria. But the value will then we won't choose this value, as we will choose a value that is available on the market, the size that is available on the market, which is 1.6 kVA.
Assalamualaikum and good morning to my lecturer, Professor Madya Dr. Muhammad Nur Ramdan bin Baharum. My name is Muhammad Badrul Munir bin Busu, metric number AE170079. I will explain about our group transformer details in the Excel software. We use transformer size of 1600 kVA, primary voltage 33 kV, secondary voltage 440 volt, percentage impedance for 5.5%, and allowable voltage drop 10%. For the calculation, rated current of transformer use formula of S total divide with Z3 times secondary voltage. 1600 kVA divide with Z3 times with 440 volt will get 2099.46 ampere. For the short circuit capacity and current of transformer, we use formula I rated transformer divide with percentage impedance. So for the I rated 2099.46 divide with 5.5% will get 38,171.92 ampere. And lastly, for the short circuit capacity and power of transformer, we use formula Z3 times with voltage secondary transformer times with secondary current of transformer. Z3 times with 444 volt and times with 38,171.92 ampere will get 29,090.91 kVA. I think that's all from me. Thank you.
Hi, my name is Tanoja, and now I'm going to present the motor detail and parameter and calculation. As you can see here, motor size is 500 horsepower. We change into kilowatt, so multiply with 0.746, and then power factor we put inside 0.8 and 92% efficiency, and then motor code T, which is the 4.1 minimum and 4.5 maximum. So you can change according to here is referring to the reference here. So code T is 4.1 and 4.5. So you can change to F and then 5.1 and 4.6. So it's change back to D. So the motor start power is 3 times as according to the instruction, and then the calculation here we using the equation as shown here. So the rated current of the motor is calculated using this equation, which is active power here divided by secondary voltage and square root 3 and power factor and efficiency, and then motor starting current is using the current here and multiply with the inrush current. And then the third one is the starting power is using the starting current and secondary voltage multiply together, and you can get, and also multiply the square tree, you will get the starting power. And then the voltage drop, secondary voltage drop is starting power of motor divided by the short-circuit capacity of motor transformer and multiply 100%, which is 7.84%, which is less than the 10% allowable voltage drop. Next, I will pass to the Ahmad to continue the presentation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Muslim bin Ibrahim. So I will explain about the result of this project. So this is the available transformer rating in the market that consists of 150 kVA until 2500 kVA. So for the first criteria transformer, full load size recommended should be 65% more or equal to the total maximum demand. So the total maximum demand is 856 kVA. So the 65% more than the total maximum demand is 1316 kVA. Thus the transformer size proposed is 1600 kVA. Because it is the closest value to the initial proposed size. For the criteria 3, if one time, then the suggested transformer size is equal transformer size chosen. As we can see, the kVA value is the same. If more than one time, the transformer size should be increased additional to 20%. So I will change it here 3 times. So we can see the result show transformer size is 4920 kVA. That means increased by 20%. So the voltage drop due the largest motor starting calculation show that 7.84% that achieve criteria 2 needed, which is it must less than 10%. So the result show all yes, that mean all transformer size will accepted depending of this criteria. So in this case, based on the technical calculation, the final transformer size suggested is 1920 kVA, but the exact rating is not available in the market. Thus, the nearest value that is higher than the actual value is chosen, which is 2000 kVA for the transformer size.